Hi everyone, this is going to be our note for 5.5, which is also the last section of chapter 5. So it just goes over, well, what if I get a situation, like what kind of technique should I use? Well, at this point, anything is fair game. So here are all of our equations that we've learned so far. We have access to Pythagorean theorem, remembering the sum of interior angles for a triangle at up to 180 degrees. We remember our primary trig ratios using SOHCAHTOA. We have our sine law and our cosine law. So we've learned all of these this chapter, and we just have to know when to choose which equation for what kind of question. So I have a nice little list of a summary that goes over when should I use each of these equations. So for sum of interior angles, it can be used in any triangle, and if I can find the third angle if I know the other two angles. We've learned about Pythagorean theorem. I can use that only in right triangles, and we can find a third side if I know the two other sides. I can use primary trig ratios also only in right triangles. I can find a side if I know one angle and another side, and I can find an angle if I know two sides. Sine law and cosine law work for any triangle. My apologies, I had to wait for that car to stop honking their horn. So we can use sine law or cosine law in any triangle, and just like our notes, from sine law, if we know two angles and a side, I can figure out the other side, or if I know two sides and an opposite angle, I can find the other angle. For cosine law, if I know three sides, I can find an angle, and if I know two sides and the contained angle, sorry, again, there was more honking, so I had to edit that. So if we know two sides and the contained angle, we can find the opposite side. So that's when we can use either of these, and if we get a question in the homework or the assignment, we can look at this little checklist to see, well, what are we trying to find? So which technique should I use? And then we can answer the question. So let's just get to an example. We're just going to do one example, and then the next little sheet that's on the note is just us figuring out which technique should we use for scenario. So in this scenario, we just get thrown a question here. It says a surveyor wants to find the distance BC in this diagram, B to C, across a river. He selects position A so that C to A is 86 meters. He measures angle BAC in that order from B to A to C to be 52 degrees, and then angle ACB to be 85 degrees. Now when it says respectively, it just means in this order. So like angle BAC will be 52, and then ACB will be 85. So the first one will be the first one, and the second one will be the second one. And it's all shown in this diagram. Calculate the distance BC, again from here to here, to the nearest tenth of a meter. So looking at this question, what technique should we use, or which equation should we use to solve for this? Well, I can already kind of get rid of some things. Like I don't see a right angle anywhere. 52, 85, there's no way that's going to be 90. So I don't really need my trig ratios. I don't really need Pythagorean theorem here. I see two angles, and I don't know this third one, so I could use sum of interior angles. So I just kind of zoom in and out. So I could do 180 is equal to angle A plus angle B plus angle C. And if I want to find out angle B, it's 180 minus angle A minus angle C is equal to angle B. I didn't line up my equal signs, but I don't have a lot of space, so please bear with me. So I'm solving for angle B, which is this one. So I'm going to move angle A to this side and angle C to this side, subtract them from 180, so I can get angle B. So we said angle A was 52 and angle C was 85. I subtract those, not divide, subtract them, and I get 43 degrees. So that's going to be for angle B. And I just wrote that in the little diagram. You can write that if you want to. You don't have to, though. So now I know an angle, and I know its opposite side. 43 degrees goes with 86 meters. So I know these two, and I want to figure out what this side is. So I do have the opposite angle to that side, though. So this tells me that I should be using sine law in this case, because I have two angles and a side. So that means I could find the other side. So let's use sine law. I'm solving for a side, so I'm going to put the sides on the top for sine law. Sine A. And I know it for the ratio of angle B and side B, so I'm going to use it for B, and I'm not going to include C in this one. So we'll put in all the information we know. Well, we don't know A, that's what we're solving for. And our angle is sine 52. Our side B is 86. And our angle B is 43. I could also just write all the stuff I know, but again, I don't have the room here. We're going to do that in the next example. So I'm just going to solve for A here, which is going to be multiplying both sides by the denominator times sine 52. And then I get, when I multiply all this and divide all this, I get 99.37 meters. Which kind of makes sense, the number-wise, because we have 86 here and 99. They're pretty close, and I mean, it's not like 1,000, and it's not like 0.5 meters. So it's in the, makes sense. So we just had to use our sum of interior angles and our sine law to figure out how to figure out that one side. So here's the homework, but we're going to do another worksheet as another example of what to use which equation when. Sorry, I almost forgot I should put a therefore statement of therefore the distance of BC is 99.4 meters, because they wanted it to a tenth of a meter. So let's practice more of these of which technique should we use. Alright, so for this next little example or activity, I guess, we're going to decide whether we should use SOHCAHTOA, sine law, cosine law, sum of interior angles, Pythagorean theorem, or if there's just not enough information and we can't use any of them. So let's start with the first one for triangle ABC. So they want us to find side B. Now what are we given? Well, we're given angle B, we're given angle C, and then we're given side C, so lowercase c, which is 30. I guess we're not going to be solving it, so I don't really need the numbers, but it's just put them in anyway. We actually don't need the numbers, so I'm actually going to erase them. So we know that information. So so looking at the information that we have, I want to find side B, and I have the opposite angle, and then I also have another angle in its opposite side, so angle C and side C. So because I have this information, I have two angles with an opposite side, I can find the other opposite side. So this is using sine law. In this case, I'm going to solve for side B, so I'm going to put side B on the top over the angle B is equal to the side of C over sine C, or the angle C. Alright, next triangle is triangle PQR. I'm trying to find side P here. I am given side R, and I'm also given side Q. And I'm also given that angle Q is a 90-degree angle, or a right angle. So we see a right triangle here, and I have two sides, and I want to find the other side. So according to our checklist, we should be using Pythagorean theorem. And in this case, we want to solve for side P. Well, that's not the hypotenuse. The hypotenuse is actually side Q. So we can say, well, we can just write it out first. The hypotenuse is equal to r squared plus p squared. I want to solve for p. Q squared minus r squared is equal to p squared. So that's the equation we use, then we can square root the other side too, but this is good enough. All right, for the next one, we have triangle DEF. We're trying to find angle F here, this one. We have side F, that's opposite. We have side E, and we have side D. And I don't see any 90-degree angles anywhere. There's no like little box to indicate we have a 90-degree angle. So I have 3 sides, and I want to find an angle. That means I'm going to be using cosine law. So I want to find angle F here. So for cosine law, we had cos F is equal to minus F squared at the end, because it's the opposite side of the angle. The other 2 sides are E squared plus D squared over 2ED. Alright, so for the last one, we knew 3 sides, and a not right triangle means I have to use cosine law. For the next one, triangle TUV, I'm trying to find side U. I have angle V, which is 29 degrees. I also have side V, which is 14.3. And I also know that angle U is a 90-degree angle. So as soon as I see 90-degree angle, it might be Pythagorean theorem, or it might be our primary trig ratios. Well, the fact that I have an angle here tells me I'm going to be using SOHCAHTOA. So we're going to use SOHCAHTOA for our primary trig ratios. And what information do I have? Well, I have the angle, I have the opposite side, and I'm trying to find the hypotenuse. So that's going to be sine, where we have sine theta is equal to opposite over hypotenuse, which is equal to sine 29 is equal to 14.3 over side u, and then we would just isolate for that by switching places. I'll just do this. We get 14.3 over sine 29, because this is the one thing we did before where these will switch places. Maybe if I drew it like this, where these can switch places as a kind of a quick kind of a shortcut. Just switch these two so that we can solve for u that way, and then I would solve and get my answer. Alright, triangle x, y, and z. Well, I'm trying to find side y. I have angle y. I also have side z, because that's opposite of angle z, and side x, which is opposite angle x. So I already see 2 sides and the contained angle in the middle. 2 sides and a contained angle. So that automatically means I have to use cosine law. Where now I'm solving for side. So it's going to be y squared is equal to, I know at the end is going to be cos the angle of y. And then the other 2 sides, which is x squared plus z squared minus 2xz. Next one, we have triangle GHJ, where here I have 3 different angles. I have angle H, angle G, and angle J. So knowing these 3 angles, I actually can't do anything, because I actually don't know any of the side lengths. They want me to solve for this side, but I have no idea what any of these other sides are relative to the side. So there's actually insufficient info, or insufficient evidence. Just making sure I spelled insufficient right. Yes. So knowing 3 angles is not enough information for us. If they gave us a side or something, then we can maybe use sine law, or potentially cosine. No, sine law would probably be better. But just 3 angles, not enough information. Alright, 2 more. So I have triangle NSW. I have 2 angles here. I have angle S and angle W, and I'm trying to find angle N. So I just want to find this 3rd angle. This one's just going to be sum of interior angles. So just 180 subtract angle S subtract angle W will give us angle N. And our last one, triangle KLM, I have angle L, which is 74. I'm trying to find angle K. I have side L, and I have side K. So I have an angle in its opposite side, and I have an opposite side and not the angle though. So because I have the opposites, I'm going to be using sine law. So I'm going to be solving for the angle this time. So sine K over side K. And then I have it for angles inside L. So sine L over side L. And those would be my equations. So just knowing what equation to use when, and just look at the information that they give you. So please try the homework and expect an assignment coming up soon. Thank you very much for your time.